Patrick Emmerling from the UR Ventures office, and today I will be discussing assessing the commercial potential of new and exciting technologies. Also, just as a just to get this out of the way, I love questions. If you have any, please just raise your hand, ask right away. Don't bother waiting to the end. People tend to forget, so feel free to ask. As you can see, this is just a little schedule for the entire series. Next one in February is a really exciting one. I highly endorse everyone to attend, working with third parties, which will be presented by Reed. So, and I'd like to thank the Dean's Office for sponsoring this lunch and learn. So my objectives today are pretty straightforward. As the title said, I'd like to discuss kind of giving you an overview of the process for evaluating nascent technologies for their commercial potential. And I'll be doing this a little bit of just the theory, but I'll also be applying it to one of our current technologies that are pretty exciting. So I always like to go back, as with anything that I do and technology transfer, UR Ventures, go back to our mission, to develop UR innovations into valuable products and services to make the world ever better. And today we're going to be focusing on the developing valuable products and services, looking at these early stage technologies and saying, okay, what's exciting about them? What is the commercial potential of them? Can we protect them? And if so, is this a technology? Is this something that we are going to invest our time, the university's capital, and our efforts to moving forward? So if you recall from the presentation I gave in November, I talked about an analogy that our director, Scott, put together on the challenge with technologies and the gulf between what's happening at the university and what's happening out in industry. So at the university, we have new and interesting ideas. We have early stage ideas and innovations. And the industry, on the other side of the chasm, has unmet market needs. These are issues that the market sees as real and as something that they may be interested in investing in, or they already are looking for solutions to deal with this problem. Because the ultimate goal is to create a viable commercial product. And so what we're trying to do is look at these early stage technologies and say, okay, does it meet an unmet market need? Is there actually a pain in the market that people would be interested in paying to have a solution to, or paying to have this technology solve the solution? In other words, to have this be a viable commercial product somewhere down the road. And in order to do that, it always starts with the inventor. And the inventor has an idea, a notion that they think might be interesting. So they perform some research. They do experiments, looking at the technology, looking at the innovation, and saying, okay, does this make sense? Is this something interesting? And if things work out well, then all of a sudden they start to develop a real idea, something that's actually innovative, something that is more than just a notion. It's something that's really concrete now, and they have some data to prove it. And that turns ultimately into an innovation, into an invention, something that they're very excited about, something they're interested in. And ultimately, they go, you know what, this actually might solve a problem that people would pay for. This is an invention. I want to move forward with this. And they disclose to our office. They let us know about it. And that is where we start, where this analysis starts, at the invention disclosure. So what I'm going to be talking about today, and the example technology I'm going to be utilizing, is one that everyone here, I'm sure, has heard about. It was in a lot of news cycles throughout the world late last year, and that's the perfect paraxio cloak design and device. Our cloak, the Rochester cloak, as it was coined in the media. So what is the technology? Very simply put, this is a cloaking device. It is a device that is designed to create a volume or an area that can be cloaked, that can be obscured, so that something can be put into that volume and therefore hidden from view. And it can be hidden from view not just from one location, but from a range of locations or viewing angles. And the really exciting thing about this is it does not require a great deal of new materials or electronics. It uses simple, off-the-shelf optical components put together in a novel way to create the cloaking area. So that's great. So we have our technology. Now, this is usually about as much information as a licensing manager will get. And the next step is to go out to the inventor and have a conversation, learning more about the technology, learning more about what they're doing. And we go through kind of a due diligence where we start with the technical, looking at it, saying, okay, well, what is the innovation? Where is it at? How was it funded? What are the other technologies? What are the other research groups around the world doing with this technology? Then we'll start to look at the market and say, okay, well, we know the technology now. Is there a market need? Is there anyone out there that has a problem that this could address? How big is that problem? How many people have it? And then who's already out there competing to solve this problem? We'll talk a little bit about the development, where the technology is today and where it needs to go. And then finally, IP protection. And once we go through this entire checklist, then we make our decision on whether or not this technology warrants a further investment of our time, whether or not it, in our opinion, has commercial potential. So let's start with the technical. I like to go to the inventors and just ask flat out, okay, tell me about the technology. You are the expert in your field. I understand it from at some level, but you're the expert, so talk to me, teach me about your technology. And really what I'm looking at is saying, okay, is this just kind of a theory, something that's on the back of a napkin or a piece of paper, and they're pretty sure it'll work, but it hasn't actually been engineered, hasn't been worked out? Or do they have kind of a prototype already in the lab, something they can show me? Those are my favorite inventions, where they can actually show me some data, or if it's from engineering or physics, they actually have a system set up I can look at and see it working. And then, yeah, if they have that prototype, is it just a kind of a proof of concept showing that, yes, this does work? Or does it really show what the capabilities could be? Is it the next generation? Then next thing I'll ask is, okay, tell me about the technical issues. Because it's very rare, and actually it can be to the detriment of a technology, if the inventor waits until it's completed. Wait until, okay, we have a product now. Really, we want to see the technologies when they're nascent, because at that point they're still nimble. They're able to pivot as needed depending on what problems they're going to address. So I'll ask, what are the technical challenges? What are still some of the areas of concern for you from a scientific point of view, from an engineering point of view? Are they minor issues, or are these deal breakers? Can you scale this up? And then ultimately, what's the time frame? Okay, we have some issues. There are some technical problems, maybe for the cloaking technology. Right now, we can cloak something about the size of a pencil. We think we can scale it up, maybe not, or yes, we can, but we're going to need to get optics that do X, Y, and Z. That's fine. How long do you think it'll take in order to get past those issues? Other things to ask, and I love asking this, is, okay, you're not only the expert in your technology, you're the expert in the field. You know who else is working on this. 'Cause most of the time, when we're looking at technology, it's not a general category. This is a very specific issue that they're working on, very specific area. So typically, there are only a few groups, maybe a few hundred researchers in the world that are really actively looking at this, publishing on this. And so I'll say, who else is working on this? What is the cutting edge of the technology? And even more so, what's the bleeding edge? What is the area that's brand new that people are just now talking about in the research community? Or it might be rumors. Oh, so-and-so is working on this. They haven't published yet, but I've heard they have some exciting results. Because those technologies are not only competition for papers and just scientifically, but those are also what could become products later on as well. So we're looking at those technologies and going, okay, they might be competition as well from a commercial point of view. And finally, when you understand the scientific competition, you can say, okay, well, what sets this apart from the rest? Why is your work here at U of R so much better than what they're doing at MIT? So much better than what they're doing in Geneva? Yeah, what about your work is remarkable? Because it has to be. If it wasn't, if they can't answer that question, then there's no reason why they're working on it. They need to be able to say that. And then getting into some of the more mundane, but just as important, is saying, okay, well, how was this research funded? Was it funded using federal dollars? Was it funded using a department slush fund? Was it funded by sponsored research, meaning that a foundation or a company invested in the lab and said, okay, we want you to do research in this area? And that actually has a profound impact, because if depending on how it's funded, usually there's an agreement that goes with the research, and they'll have IP language. And especially for sponsored research, more than likely that technology is encumbered. It might be that the company has the right to see the technology, see an invention within 30 days of it being disclosed. And they have an option period where they can license the technology outright. Or, worst case scenario, they might already have the rights to any intellectual property. We need to know this so that we know what we can do moving forward. Also, I'll ask about future funding, saying, okay, well, you've been working on this for X amount of months, years. That's great. You have had funding so far. How are you going to continue to fund the research? Is the research going to be continuing? If they're running out of grant money and they're moving on to a different area where they have funding, that's an issue, because if there are technical issues that need to be addressed, but now their funding source, NIH, NSF, DARPA, are focusing them in a different direction, they're not going to have time or interest to deal with the technical challenges that come for this technology. Yes?
Should they be looking at getting a patent at each stage of development to protect their intellectual information?
It depends. Really, what I always suggest to our inventors is, if they think they have something that's novel, disclose it to our office. I'd rather the researchers disclose often and early. We'll go through the evaluation and we'll make a decision on whether or not it warrants patent protection. If it does, for example, let's say they're about to give a presentation or they're going to do a poster, then we definitely want to evaluate it quickly and protect it. If there is no impending disclosure and it's still a little too early for a patent or protection, we might say, okay, we're going to wait for further research. But it's always good to keep a close conversation with the UR Ventures office. Yeah.
Through the different iterations of patents, are they different? I mean, can you pay at the same price for patent at the different levels of development?
As the technology develops, we can patent. There could be continuations in part or divisionals. There can be branch-off points to create a patent family. Reed did a great presentation a few months back on that, and it's actually on the UR Ventures YouTube page, the presentation. But we can talk about that further offline. But yes, you can definitely create a patent family.
Thank you.
No problem. So once we've gone through those technical questions, we now have a much better understanding of this new and nascent technology, this exciting technology. What we need to do now is to start looking for that unmet need, for that market need that would be that could be helped by this technology and ultimately can result in this being commercially viable. So I'll start to ask questions, not just to the inventors. I like to have the conversation with the inventors as well, because more often than not, they've identified problems they think the technology can solve. But I'll also, and I'll get into the details of how later, we'll start to ask questions outside of the university, start to look at research to figure out, okay, well, what are some of the real-world applications of this technology? For the cloaking technology, we went through a number of them. Obvious, there are military applications. You could very easily see military applications to a technology that allows you to hide something. Telecommunications is another area we thought would be interesting that also branches into the security as well. Whether or not it's satellite technology or even drones, depending. The beauty of these is with the cloaking technology, it's not a 360-degree cloak. While it has some degrees of freedom where the different angles that the viewer can be looking at, it is a discrete amount. So with these, they're high enough up that someone on the ground looking up or looking through a telescope might not be able to get to a vantage point where they would go beyond the cloak. So for these, technology might be very interesting. Another area actually came out of my brother-in-law's family. They live out in Cape Cod. And years back, I remember hearing them complain about the wind farm that was being suggested going out into the Atlantic, off the coast of Cape Cod. They'd barely be able to see it, but they were screaming bloody murder. This would ruin the views. Well, if you had a technology that eliminated that from the view, those are still out there, but now no one on shore could see them, might be viable, especially if you could scale the technology up to cover something that big. But these are all potential applications. So you say, okay, great, those are all could-bes. But what are the current alternatives to what we're talking about? What's already out there trying to solve the problems? For the military, it's obvious. They've been working for decades on camouflage technology, whether it's working for the Army personnel or protecting larger assets. They've been working on that. They have solutions already on the ground. Through research groups, you see a lot of articles. I saw one just a few weeks ago on metamaterials. These are materials that have been engineered to have unique or outright bizarre optical properties, something that you would not see in nature. Typically are composed of a metal and an insulator, but these are unique materials coming out of MIT, Duke, Berkeley, what have you, that could be used potentially to cloak not just optically, but they could cloak other wavelengths, whether it's in the infrared or even in microwave. And then finally, active camouflage. And this is an interesting one. I think a number of people here would have seen through news reports. Came out of the University of Tokyo, and what they used was a system of a camera and a projector, and then a literal cloak that an individual could wear, have the images that the camera behind them is picking up projected on them, and then technically they would have a form of cloak. So, okay, now we know what's out there. We have an idea of the technology. We have an idea of some of the problems. We need to ask ourselves, what sets our technology apart from all the rest? What would make this technology be elevated above them? And for our technology, really it comes down to three areas that we see as exciting. The cloaking volume is continuous. Most of the technologies that are doing optical cloaking are very good as long as you are standing and looking at them from a specific line of sight. But if you move your head or move your body to a different viewing angle, you can not only see the object that's supposed to be cloaked, but you can see the entire device. For this system, you actually have several degrees of freedom. You can move up to plus or minus 15 degrees in 3 dimensions, and you're still having the object be cloaked. So that's exciting. Second is scalability. Because this utilizes off-the-shelf optical components, it doesn't require the engineering of unique or potentially difficult or expensive materials in order to create this. So it could be potentially readily scaled. And then finally, it overcomes some issues that many others have with background discontinuity. And this is one thing that really excited me. If you can see in this picture, everybody's seen this picture from the news reports, but if you really look at it, you'll see the grid in the background, the blue lines as well as the red and the green. If you're looking through the hand, you can actually see that the blue lines cross where you'd expect them to. That's important. But even better is if you start to move your head and walk around and looking at it, those blue lines and the rest of the grid will move appropriately. So the lines are where they're supposed to be. A lot of cloaking technologies, you move your head even a little bit, the lines will go in a direction that makes absolutely no sense. So you'll lower your head and they'll move diagonally. Yeah, it's obvious as you look and as you move that there's something there. There's something odd going on. With this technology, they were able to overcome those issues. So now we know about that a little bit, but I always like to ask, okay, well, we've got that idea. Are there any other potential applications, something beyond the obvious? And for this technology, I thought of the automotive industry. I was saying, okay, well, yeah, those other things are great, but what if you can make it so that there are no blind spots in a car? That if the driver turns his head or her head just slightly, they can see the card that's in their quote-unquote blind spot, because now that blind spot's been eliminated through the use of this technology, or even the bar, as it shows here in front. Yeah, if you can eliminate those, that might be very interesting. I don't know if there's a market there yet, but this could be another potential application, trying to think of ways that the technology can pivot to address problems. So this is all well and good. We have ideas on how it could be commercialized. What we really need to do is say, okay, well, is there in fact a market need? And the very standard way of doing this is to do market research, where you go to a Frost & Sullivan, identify reports that have been done on this market. You're hoping that they are relevant, that they're relatively new. Read through them, see what their analysts have said, and go, okay, great. You know, this market is so big, it has X billion dollars. Here are some competitors. It's a growth market. Interesting, useful, and necessary information, but definitely not the final spot. What we like to do in our office, and I'm a big fan of, is to use the lean commercialization methodology, where you say, okay, we understand the technology, but we need to go out, get out from our offices, get out from the university, and go talk to industry experts to find out really what is the pain in the market and who are our customers. It's called customer validation, it's called problem validation and customer discovery. And so the first thing that you do is you go out and you say, okay, I'm going to create a hypothesis and say, this is what I think the pain in the market is, and this is what I think the value proposition for the technology would be, or how the technology would be able to address this pain. And then you go and identify people in the market who are industry experts. They could be the end users. They could be people who work in companies. And you have non-confidential conversations. Over coffee, these are not easy to get, but they're very important to do. And you ask them questions. You ask them, okay, is this a real pain, my hypothesis? Is this a real pain that the market is feeling? Is this something that impacts your daily life? If yes, great, could you tell me more about it? If no, really, what is the pain? What am I missing? And what you're doing is going out there and you're literally with feet on the street, you're going out there and interviewing people. You're learning about a small subset of the market, finding out more about what they really value, what they would invest in. Because oftentimes what we think is the problem in the market, when we go talk to people, they say, oh yeah, that's an issue, but we already have 100 solutions for that. That they're not the best, but they're cheap, everyone knows how to use them. What the real issue is, X. This is, if you could find a way to solve that, that would excite me. You say, okay, you take the notes, you acquire the data, and then you move on. You keep talking to people. And the more people you talk to, the more you're going to learn. And what ultimately may happen is that you say, okay, my initial hypothesis was wrong. I need to pivot. I need to look at the technology from a different point of view. And as you continue to do this, what you're going to end up doing is developing an idea of what the market really looks like, who your customers really are, and then from that you can say, okay, well, this is the value proposition that we would need to bring to the market, to the end users, in order to get them excited about this. And then you turn and talk to the inventors and look at the technology and say, can the technology address this? If today, yes, great, no, fine. Is there work that could be done with the technology to investigate, to see if it could branch off in a different way? You know, so you look at this and then you can start to develop in your mind, okay, well, this is how it would have to be commercialized. If this is our value proposition and this is the customers that we're trying to reach, you go through the process, the business model canvas, and say, okay, well, then these are the channels I would need to use. Here's an idea of the revenue. And then what are the partnerships we would need to have? What are the key resources? How much would it cost? And with an understanding of that, then the licensing manager can turn around and say, okay, well, would this be a startup company? Or should we license this to an existing company? What makes the most sense? Because from a licensing manager's point of view, my customers aren't the end users. My customers are the people that I would be licensing this technology to. So first step for me is to understand what they would be addressing, what their opportunity would be, and then develop my own strategy to reach out to them, to get them excited, to show them that this technology could address their customers so that they could reap the benefits. Perfect setting, they've already figured that out and they're coming to us, but more often than not, we have to do the legwork. And then we can get to work on negotiating a license if we decide to. But we need to have an idea of the commercial opportunity before, even though this, as the technology evolves, this will change. It's an iterative process, but we need to have an idea of it at an early stage. So now we have our technology. We've identified a potential market pain that's unmet. Now we have to start thinking about that commercially viable product in the process of getting it there. And to do that, I like to look at the technology again and go, okay, we have a much better idea of the market. We have an idea of what kind of products this would need to evolve into in order to actually add value and be commercially viable. What's it going to take to help the technology move forward enough that someone in industry would recognize this value and be willing to take on the risk of developing the technology further? Because these technologies are not going to turn into products here at the university. We need to license them out. We need to, whether it's a startup or an existing company, doesn't matter. We need to get them off campus if they're going to have any chance at moving forward as a viable product or service. So what development work needs to be done? Can it be done here? Are we at a point where we could develop a prototype? Do we need to go beyond that? How much is that going to cost? How long is it going to take? Now, there are mechanisms here at the university that allow for that. The Technology Development Fund is a prime example. The focus of the fund is to help technologies that have real commercial potential move the commercialization needle, to take a small enough step forward that they can get further funding, to take another step forward closer to the marketplace. But we need to address that. And then the next part that really is critical is saying, okay, now that we have an idea of the technology, of the market, and how it would need to go forward, we need to talk about the intellectual property. And when it comes to patenting, you don't want to do this just in a vacuum, saying, okay, well, here's what we have in the lab, we'll just write claims associated with that. You really are trying to think ahead, think about what the market would need, because you want this patent or patent application to have real commercial strength. You want it to be something that they can use to block others from the market so that they can move forward and their business can be successful. So we need to think about that. And then we start to talk, okay, well, is this something that would warrant a patent application? Or would it be a copyright? Or should this be a trade secret because the prior art makes it so that no one would be able to file a patent application on it? Now, we could go into a great deal of depth on the subject, but Reed has done an outstanding job presenting about intellectual property and prior art searches already, so if you'd like to learn more about that at great depth, I would suggest you go to our UR Ventures YouTube page. Thanks to Dave's hard work, we have great videos of those presentations as well as the PowerPoints. So we've gone through the due diligence. We've looked at the technical. We've looked at the market. We've discussed the development and where we think it would need to go and the intellectual property. Now comes the hard part. Taking all of this information, we have a decision to make as a licensing manager and as the technology transfer office on campus. Do we move forward or do we not? Does this technology warrant the investment of the university's capital, of our time and commitment to take it from where it is today, protect it, and try and commercialize it? Once we've made that decision, we go back to the inventors and let them know. They're always a part of the conversation, but ultimately we have to make this decision based on what we learn from the technology, from the market, and from the IP. And we let them know what the decisions were, and we go from there. So that was a very quick run-through of the process. Well, no more questions. Thank you very much for your time, and have a great day. Also remember, next month, Reed will be presenting on working with third parties. This is an excellent topic. and very important. So I highly endorse everyone join us for that one.